90 divided by 1 plus 271 e to negative 0.122x. Models the percentage P of x of Americans who are x years old with some coronary heart disease. So x age, P, percentage of Americans who are x years old at a particular age group with some coronary heart disease. Problem 43, or the first question, part A. What percentage of 20-year-olds have some coronary heart disease? What percentage at the age of 20? If the model is true, I will have to find P of, very good. Don't do anything. Let's continue, and then we'll come back with all of them at once. What percentage of 80-year-olds have some coronary heart disease? So P of 80. At what age? At what age is the percentage of some coronary heart disease 50%? And then at what age is the percentage of some coronary heart disease 70%? So first, let's finish this one up. Let's go to y equals. So in y equals, please clear if you have anything in there. And let's punch in 90 divided by 1 plus 271 times e. Here's e right here with natural log. Don't forget parentheses. Negative 0.122x. Close the parenthesis, get outside, and close the parenthesis again. So 90 over parentheses 1 plus 271 times e to negative 0.122x, close and close. Now I go to second and table. I punch in 20. I punch in 80. And I get everything at once. So P of 20 is 3.66%. And P of 80 is 88.61%. So what will you say? Please translate. What does 3.66% represent? If the model is correct, what percentage of the age group of 20 apparently have some heart issues? 3.66. If the model is correct, in the group of 80-year-olds, how many of them, again if the model is correct, how many of them apparently have heart issues? Almost 89%. Any questions on this? The table works, but the function may not be correct. Oh, no, it's second the table set. You have to go. Okay. So,
You can put the equation back into the calculator.
You have to put parentheses for the power and parentheses for the denominator.
You
Say
can
it
put the
again?
equation back into the calculator again.
Yes. So be very careful with parentheses.
How do you do E?
With natural log. Yeah, second and natural log. I put it in my put minus instead of division. Is it okay? Everyone? always, guys, cover your cups and stuff like that. Because that's how I got it somewhere. I can't accuse anybody of anything. But always. Okay, so now the last two sections. The last two questions here. Antoine, are we okay? Yes? Okay. At what age is the percentage of some coronary heart disease 50%? What do I have to do now?
Go back to your table.
No? Tim? Say it again, I'm so sorry. Yes. So 50 equals, no. P of whatever is 50. I don't know the age. 50 equals 90 over 1 plus 271 e to negative 0.122x. Okay, so when you look at this equation, what do you see first? What do you see first? First, you have to see the big picture, and then you can go into details. So what is the big picture here? Say it again.
90 over 2.
Right, so what type of equation? What type of equation? What is the big picture? What equation do I see? Rational, very good. So if it's rational, then what do you do immediately? Cross multiply, awesome. That's all I want you to say. So then 90 equals 50, 1 plus 271 equals 1.22x. Very good. Good. That's the big picture. I'm not there at the exponential yet. I will, but I'm not there yet. Okay, then. What would you recommend we do next? Yes, or that's awesome. It's not a mistake. Or what is the other option? But you're right. I can distribute. Instead, I would like to divide. 9 over 5 equals 1 plus 271 e to negative 0.122x. I divided both sides by 50. 90 over 50 is 9/5. I'm trying to clean it up. If I had distributed 50, I would have gotten the same, eventually the same answer. Good. Now, what do I want to get rid of? Exactly. How much is 9 over 5 minus 5 over 5? Very good, awesome. 9 over 5 minus 5 over 5 is 4 over 5, 271 e to negative 0.122x. Awesome. What do I want to get rid of now?
271.
Indeed. I will divide both sides by 271, or I will say I'm multiplying by 1 over 271, both sides. And do not bother with multiplying, or if you want, you can. Doesn't matter. Now this is finally plain exponential. And what do I do to both sides? Exactly. Apply finally natural log to both sides. So natural log of 4 over 5 times 271 equals negative 0.122x, and x equals this over this. Natural log of 4. Let's multiply because I don't want you to make a mistake when you plug it in. So it's, bless you. Okay, over negative 0.122. So in the graphing calculator, carefully how you put it in. Okay, clear. Okay, natural log 4 divided by 1355. And divide by, in parentheses, negative 0.0, no, not 0, sorry, 122. Okay, so 47, roughly 48. What does this mean? That at the age group of roughly 48, it appears that 50%, according to the model, I'm not saying that the model is true, I'm not saying that it works for everyone, but it appears that according to the model, roughly 50% of those 48, 49 years old have some disease, some heart issue. Okay. Any questions for me? Any questions for me? Any questions? I'm sorry? Yes, of course. Uh, 37. The logistic growth function is given to us. F of t equals 100,000 divided by. Oh yes, of course. I'm so sorry. Thank you, David. 5,000 e to negative t describes the number of people f of t. So f of t, number of people who have become ill, and now I know it's the first time ever, with influenza t weeks after its initial outbreak in a particular community. So t, number of weeks. How many people became ill with the flu when the epidemic began? Say it again. What does that mean? I gave it to you. No. Initial. When we say initial, what do we mean? Exactly. So f of 0. So let's do this together. 0 with minus 1. T e raised to 0. E raised to 0. 1. 1 times 5,000. 5,000 plus 1. So how much is 100,000 divided by 501? No approximations? 20. Okay? If it's 20.1, it's still 20. If it's 20.8, it's still 20. I can't round down number of people. Good. Part B. How many people were ill by the end of the 4th week? So how do I find that? What do I have to do? Indeed. Okay, so with the graphing calculator, 100,000 divided by, in parentheses, 1 plus 5,000 times E, and that is negative 4, close the parenthesis. And let's see what we get. 1,080. Okay, part C. What is the limiting size of the population that becomes ill? What is the maximum possible? Say it again. So let's look at this model. So 100,000 over 1 plus 5,000 e to negative t. Let's put the function in the y equals. So 100,000 divided by, in parentheses, 1 plus 5,000 times e to negative x in parentheses, negative x, close the parenthesis and close the parenthesis for the denominator. So let's read the question one more time. What is the limiting size of the population that becomes ill? So what is the maximum possible number of people that can become ill?
100%.
So, right, correct. But we have to determine the number. So, in other words, assuming this, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 2. So this room holds 24 people. Let's say one desk for me. And let's say there is no more than 25. Okay? So let's assume that in this room there are no more, nobody can get in after there are 25 people in. So what is the maximum number of people who could get ill in this room? 25, right? So as time passes, one person is ill, then maybe 2, and maybe 4, and maybe, but it cannot exceed 25 because we only have maximum of 25 people here. So as time goes by, even if I say 5 months from now, or it's in weeks. So let's say I say 20 weeks from now, still maximum 25. 40 weeks from now, how many? And so on and so forth. So now, I will plug in 4 weeks. I know the answer. I will plug in 10 weeks. I know the answer, 81,000. I will plug in 40 weeks. I will plug in 60 weeks. I will plug in 70 weeks. I will plug in 2,000 weeks. So what is the maximum number of people, according to this model, that can get ill?
100,000.
What is that for this function then? As x increases without bound, horizontal asymptote, y equals 100,000. As x increases without bound, so I will say as x, increases without bound, this is no more than 100,000 people that can get ill. Okay, any questions? Any questions from me? Okay, yes?
In the part A, where you got 5,001 for the denominator,
Yes?
can you go through the function or the process where you got 5,001?
Yes. Plug in 0,
Okay.
and I got 20.
No, sorry, let me explain. Yeah, how you kind of set up the formula where e to negative t, and then that cancels itself out.
0.
Yeah,
0.
that works.
E to 0. 1. 1.
So 1 is there.
1 times 5,000.
Okay.
Plus 1.
Plus 1. So why is e minus t 0?
T is 0.
Oh.
0 times negative 1
Gotcha. That
is
made no sense to me.
That's okay. That's okay. Very good. Okay. Chapter 5. This should not be new. This portion should not be new. This was dealt with in previous courses. Systems of linear equations in 2 variables. Systems of 2 linear equations in 2 variables. Can anyone tell us what is a system? What is a system of 2 equations in 2 variables? Well, 2 conditions put together. So let's take a look at the following. Problem 8. You will remember this. You'll see in a minute. Very simple. 2x minus 3y equals negative 13. And y equals 2x plus 7. These are two equations. What type of equations are they? Linear indeed. And how many variables we see in this system? Two. So there are two methods that we will look at right here in this section 5.1. Substitution. Yes, very good. And elimination. So let's solve by substitution only because the second equation is already solved for y. So if we're told that y is the same with 2x plus 7, it means that I can use this information and plug it in the first one. You remember this, right, Tim? So then this is basically replaced. Y will be replaced by 2x plus 7. So can anyone dictate the first equation? So I make sure that everything is clear.
We didn't do decay. We do decay.
2x minus? Yes? We'll go back to decay. In parentheses, 2x plus 7 equals, but if you,
Plus 13 equals 0.
okay, but for now this will be linear. We don't have to move terms around. This is not going to be quadratic. I don't need 0 on one side. So you can move 13 to the other side, but then you will bring it back because it's linear. So it's not a mistake. You can move it, but then we'll move it back. Good. So then this is 2x minus 6x minus 21 equals negative 13. Right? So negative 4x. Now we have to bring 21 to the other side. 21 minus, that's 8. So then x equals negative 2. Is this done? No. I determined only x. So I have to go back and determine y. So I go back with x in here and replace x by negative 2. 2 times negative 2 will be negative 4 plus 7 is? Good. So then it appears that the solution is I have no idea if that's true. I will have to go back and check. So this is negative 2, 3, and this is negative 2, 3. Let's do this together. 2 times negative 2 is negative 4. Negative 3 times 3 is negative 9. Negative 4 minus 9, correct. 2 times negative 2, negative 4 plus 7 is 3. 3, correct. So I know that this is the correct solution. And this was done using the method of substitution. Okay. Let's take a look at another one with the method of elimination. Let's say 24. 2x minus 7y equals 2, and 3x plus y equals negative 20. Okay, so in this particular situation, we would like to use the elimination method. We would like to choose. I'm sorry? No, we're not graphing. We are not graphing. So we want to, for this particular situation, we want to use the elimination, also called the adding method. The adding method. I have to make a decision which variable I would like to eliminate. And here is the decision process. First of all, I have to make sure the system is presented in this particular order. X below X, Y below Y, the equal symbol below the equal symbol, and the free term below the free term. This is the key, number 2. I look at the coefficients of x, 2 and 3. I look at the coefficients of y, and I'll explain in a minute why. Why? -7 and 1. Yes. If I multiply the second equation by a particular number, when I add the equations, these two will go away. What do I multiply the second equation by? Correct. So why I said for x, will I get the same answer? Of course. But if I choose to eliminate x, I would have to multiply this by 3 and this by -2 to make the 6 and the -6. And if I can avoid multiplying both equations, why not? So I will only multiply the second equation by 7. Remember, you cannot choose and pick. You have to multiply both sides, everything. I copy the first equation. 2x minus 7y equals 2. And then 21x plus 7y equals -140. I multiplied each and every term by 7. So now, these two, by plan and by design, they went away. I combine, I add what I see. So 23x equals -138. X equals -138 divided by 23. How much is x?
-6.
Is this done?
No.
No. I have to go back, and let's say I go back here. -18 plus y equals -20. So y appears to be -2. The ordered pair sorry. The solution appears to be with a question mark. I have to go back to the original problem. -6, -2, -6, -2. -12 plus 14. Check. -18 minus 2. Check. And then I will say yes. Yes.
Where is the -8?
5, 6, and 2.
Very good.
What did you, in words, the second necessity use, the adding method? So first one, we didn't have matching order, and then
If we don't have them arranged in that order, then I have to rearrange the equations. That's never a problem. I can move terms around. I can arrange the way I want.
what was the second one?
The second one, I decide which variable to eliminate based on their coefficients. So because I see here 2 and 3, and then -7 and 1, I prefer eliminating y, but it doesn't matter. If I eliminate y and you eliminate x, we will still get the same answer. And this is the only one.
Okay, thank you.
Okay. Next. 6.1. Matrix solutions to systems of equations. Well, these are higher level systems, like 3 by 3. 3 by 3. What does this mean? Well, it means 3 equations in 3 variables. 3 equations in 3 variables. Okay, my department decided that I have to show you by hand a method from here, a problem from here, and using the calculator, any of these. So allow me to show you by showing you the calculator method, and then I'll go back to a by hand method. I only have 10 minutes left, and I don't know if I can finish one by hand in 10 minutes.
Are we gonna have to do it?
I'm sorry?
Is that a thing we're gonna have to do on testing?
You mean this is showing the step-by-step method?
The one that takes 10 minutes.
Oh, the first one always takes longer.
Oh, so it doesn't always take 10
Right?
minutes.
No, it will not. It will not.
Okay.
But the first one, if you remember, like with anything, I talk a lot, I explain a lot, but then the second and the third and the fourth I take less and less. Okay. So here's a problem. Let's say 29. On page 631. X plus 2y equals z minus 1. Second equation, x equals 4 plus y minus z. And the third one, x plus y minus 3z equals negative 2. Look at the system and please tell me, I know what you have to do first, mandatory.
Line them up.
Say it again.
Line them all up.
Exactly. Line them up. X under x, y under y, z under z, equal symbol, and a free term. X plus 2y minus z equals negative 1. Do we agree with the first equation? Can anyone dictate the second equation? X minus y plus z equals 4. And the last one is done. Okay? Okay. Say it again. You can use elimination if you want to. However, we are talking about matrices here. A totally different situation. It's not about elimination and it's not about substitution. It's a totally different method. First, the matrix of coefficients. The matrix of coefficients is denoted by uppercase A. And then 2 big brackets. And these brackets, I will copy just the coefficients of the variables in the correct order with spaces, like just array of numbers. 1, 2, negative 1. 1, minus 1, 1. Last one, 1, 1, negative 3. Next, the augmented matrix. Looks like this. A vertical bar, and lowercase b, with brackets around it. And this is the same matrix, but it has an additional column. I copy the 1, 2, negative 1, 1, negative 1, 1, 1, 1, negative 3. And this extra row, forgive me, this extra column is represented by the free terms. Negative 1, 4, negative 2. Any questions? Any questions? Okay. Next step. I'm debating with myself whether to show this by hand. Hmm?
Makes it easier to understand the calculator.
I agree. Okay. In order to solve the system using operations on a matrix, there are three basic operations. I will not be able to finish it in 5 minutes. 3 basic operations. Operation number 1. We are allowed to swap lines or rows. I'm allowed to swap lines or rows. What does this mean? Do you think that the solution to the system, if I choose, for whatever reason, if I choose to take this equation and put it instead of the first one, and take the first one and put in the second row, in other words, swap these two, do you think that the final solution will be different? Absolutely not. It doesn't matter, right? So if you have your own business and you consider the number of people first and then material, or you consider the material first and then number of people, still it's not going to make any difference. Your profit, maximum profit, will still depend on the whole thing. It doesn't matter. Okay, so I'm allowed to swap lines or rows if I want to. Number 2. I am allowed to multiply or divide a row by a non-zero, of course, number. That's the second allowed operation. What does this mean? Here's what it means. Do you think that the final solution of the system, if I decide, for whatever reason, to multiply both sides of this by 10, 10, 10, 10, 40, do you think that the final solution will be changed? No. Multiplying both sides or dividing both sides of any equation by a non-zero number is not going to affect the final solution of the system. Final possible operation, just 3. And we have to stick within these 3. We cannot invent anything else. Is multiply or divide a row by a non-zero number. And you can say, you just said that. Yes, but there is not, that I didn't finish. And add this result to any row, to another row, I should say, better. This result to another row. So how does that translate here? Here's how it does translate here. Do you remember a few minutes ago what we did here? We multiplied this equation, both sides, by 7, right? We have it here. And then we added the result to another equation, and we got this equation. One more time. We multiplied this by 7. We got this. And then we added this equation to another equation, and we obtained a third one. That's why we are allowed to do this. So I'm allowed to multiply or divide a row by a non-zero number and add this result to another row, as we just did in a 2 by 2. I know it's 9 o'clock. So what are we going to do? I'm going to end here. On Wednesday, using exactly these 3 basic operations, nothing else, we are going to change this augmented matrix, bless you,
Thank you.
from this. We are going to apply to this these operations. I'll show you how. To eventually get this. 0, 0, 0, 0, 0, 0, 1, 1, 1. And I'm just making this up. I don't have the answer to the system. Okay, I don't. So I'm gonna put here A and B and C. Not to confuse you, because I don't know. I have no idea what the answer is going to be. So once I present this matrix like this, can anyone from here identify how much is X, how much is Y, and how much is Z? But I have to make it. I have to go step by step and change that augmented matrix into this, and then I'm done. I will say X must be A, Y must be B, and Z must be C.